Good morning, students. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. I am taking this subject, Engineering Mechanics. This is our 10th lecture, and this subject belongs to the third semester of Civil and Mechanical Engineering. Let us recollect what we learnt in the last lecture. In the last lecture, we learnt about the moment, then about the principle of moment, then Varangian-Thorne, then about beam, types of beams, types of supports of the beam, types of loads on the beam, and two problems based on the above concepts. Now, let us recollect moment. Moment is the turning effect of a force is called moment. For example, there is a lever, this, and this is the moment center about which it is rotating, and we apply a force, say F, like this. And this vertical distance is D. Then this beam, this lever will tend to rotate in the counterclockwise. This is called M. Then we define M equal to force into vertical distance, and unit becomes Newton meter. Now, if this lever is same moment center, this lever is called, the distance is called moment arm. But now, if force applied is like this, making an angle of 45 degrees with the lever, then at this distance is D, then the force into vertical distance, we define it, moment equal to force into vertical distance. For that, we just extended back the line of action of this force, and we drop a perpendicular on it. Then if this distance is say x, then in that condition this force was F, M equal to force into x, because the shortest distance on the line of action will be the multiple for the force, and shortest distance will always be a vertical on the line of action. Now again we acknowledged that the moment M is of two types, that is bending moment. We normally represent it by M, and then the turning moment. Unit is same. Then I gave some practical know that just you take a scale in your hand and hold it from one side and try to push it from the center of the edge like this. This will get bent like this. So it is giving a bending moment. But again, take this lever, and this is scale in your hand, and try to rotate it from one corner here. Then this will be getting a bend, but at the same time it will be getting a twist like this. Then both bending moment and turning moment are acting on it. Now again take same scale and try to rotate it by pushing, applying a force from here direction and from the top. Also equal and opposite. This force and this force must be equal and opposite. F vertical upward, that is upward, and F downward should be equal. In that condition, you will find that it is just getting twist only, no bend. And these two equal and opposite forces, this and this, will be called in that condition a couple. Couple is a equal and opposite forces acting at some distance. If they are acting on same line of action, then they are not couple. But if there is a gap between them, then it will be called a couple. It is having some characteristics we will talk when we are taking this topic especially. Now, then we applied the principle of moment, in which we stated that if a body is acted upon by a system of coplanar non-concurrent force system and body is in static equilibrium, then the conditions of static equilibrium are summation F horizontal equal to 0, summation F vertical is equal to 0, and summation M equal to 0. Then what is meant by summation M equal to 0? Summation M equal to 0 means that the clockwise moment and anti-clockwise moments are equal. And this is the principle of moment. Then if a body is in conditions of static equilibrium, then horizontal forces will balance each other, the vertical forces will balance each other. It means this summation Fx going this way will be equal to Fx going this way. Similarly, y going this way, the force Fy going this way will be equal. Similarly, M counterclockwise will be M and clockwise. Then conditions will be fulfilled, and this is the principle of moment, that when a body is in static equilibrium under the action of coplanar non-concurrent force system, then its sum of the moments will be 0. It means the counterclockwise moment, sum of the counterclockwise moment will be equal to the sum of the clockwise moment. Now, coming to the Wigner-Thom. Wigner-Thom, it is very important. As I told you yesterday also, it will be used left and right in every aspect of engineering, be it electrical, electronic, mechanical, civil, everywhere. With this principle of moment will be used as a tool to analyze many type of problems. But there we will be using a different way. For example, we will be using this principle of moment to find the center of gravity, centroid of a body. In the coming units, we will deal how it is used. But for now onward, now the Wigner-Thom states that if a system of forces acting on a body, then sum of the moment of those component forces will be equal to the moment of their resultant about the same moment center. For example, let us take this is a line. On this line, these many forces are acting, and we three forces, say 20 Newton, 30 Newton, 50 Newton, say 2 meter, 2 meter, 3 meter is the gap. This is the moment center A. Then the moment of these forces about A will be, say, equal to, taking counterclockwise as negative, then 50 into 2 negative plus 30 into 4 plus 20 into 7. You can make calculation. This is 100, 120, this is almost 60. Okay, then it states that if there is a resultant of these three forces and passing through, say here, then this will be equal to r into this distance of this distance is say x. In that condition, then we can say the sum of the moment of these forces will be equal to the moment of their resultant about the same moment center A. Then we defined a beam. Beam is a structural member which is kept horizontally and loaded across its length, like this. Hence, it will be having some supports. This is the roller support. This is the hinge support. Similarly, there will be a fixed support also. This is a fixed support here. Then type of loads we calculated. If you just use any type of loading, that can be distinguished when seen closely or analyzed closely into three type of load. That is, this is the beam here hinged at one end and giving a roller support at other end. It can be loaded. This is called gradual load, then point load, or then uniformly varying load. This is a triangular loading, this is a rectangular loading, and this is a point loading. This is point load, this is uniformly applied load, this is uniformly varying load. Then we solved two problems based on these two. Now we will solve some problems based on what you have learnt in the last lecture, and today I revised it again. Take this problem. Here, what are the forces and moments transmitted by the compute the simplest resultant force for the load acting on a cantilever beam as shown in figure given below. What force and moment is transmitted by this force to the supporting walls at A? This is the supporting wall. This is the supporting wall at A. This is the UDL, uniformly distributed load up to this line. From here to here, it is UVL, and this is a point load acting upon it. Now, first of all, we have to convert this uniformly varying load, a uniformly distributed load, into point load. If you can recollect this total load is, this is given 7 Newton per meter length. It means this total length is 6 meter. It means there will be a 6 into 7, 42 Newton load total on this portion of the between A and D. Then because this is the uniformly distributed load, it is a rectangular in section, hence its center of gravity will lie in the center somewhere here, that is 3 meter from end A. So we have converted it to equivalent point load by multiplying this distance into the unit load, that is 42 Newton, acting at its center of gravity, which is at the 3 meter distance from A or 3 meter distance from D also. And because this load is total length of loading is 6 meter. So this is our 42 Newton and virtually acting at the center of gravity, which is 3 meter apart from A. Now take this uniformly varying load. This is a triangular loading, and you know right angle, what is the area of right angle triangle, which is half into base into height, that is 7 into 21 divided by 2. Okay, and where it will act? It will act at its centroid. Its centroid for the moment, just remember, it is 1/3 from the base. 1/3 from the base or 2/3 from the apex top. So it is somewhere here, which is 7 divided by 3. This distance is 7 by 3, or this distance will be 2 into 7 by 3, which will be coming out to be 4.67 or 2.33 here. Total will be 7 up to here. Now total load is 21 into 7 by 2. Now what we have done, we have converted this UDL into a point load here. Then we have converted this UL also into a point load here. This load is acting from bottom, so it is acting upward, giving a counterclockwise moment, and this is acting downward, giving a clockwise moment. You can just analyze it as with respect to the point A. So the total load is half into 7 into 21, that is 73.5 Newton, and it is 2/3 from the apex point B, that is 2 by 3 into 7, that is 4.67 from the apex, from the point B. Same thing. Now just we have again chosen drawn that cantilever. This is the cantilever we have drawn. This is point load 42 Newton. This is 500 Newton upward, and this is 73.5 Newton upward. Hence, the resultant force acting on the wall, which will be giving it a upward thrust like this, will R 42 minus 73.5 minus 500, this much. This will be trying to lift the cantilever upward, but its reaction will be downward. This is the reaction. Now comes the about the moment. Just listen, analyze carefully. This 42 Newton force will be giving a clockwise moment. This 73.5 will be giving a counterclockwise moment, and this 500 again will be giving a counterclockwise moment. That will be, this is 42 into 3 clockwise, taking clockwise positive. Yes, clockwise moment we have taken positive. Okay. So 42 into 3 minus 500 into 12 minus 3.5. This is the 3.5 distance. Total distance is 12. Then 73.5 into 12 minus 6.46. This is 6.46. So we have, 4.67. So we have subtracted from the total length, because this length will be 12 minus 4.67, and this distance will be 12 minus 3.5. That, and this sum comes out to be minus 4662.75 Newton anti-clockwise. This is the resultant, and is the answer. Now take another problem, that is 3.113. I have referred these numericals I have taken from the Dr. D.S. Kumar, Engineering Mechanics, Kataria publication. Very nice book, you can refer it. And if you want to purchase it. Very nice books for basics of engineering mechanics. Fundamental books, you will enjoy it. Determine the reactions at A and B for the beam loaded as shown in figure 3.22. This is the beam. Here, this is the hinge support, this is the roller support. So, hinge support means that it can have a thrust like this reaction for this force. Its horizontal component will be having a thrust like this, its vertical. This we will be having two components. One is giving a horizontal thrust, one is vertical. This, to counter this thrust, this hinge will be having a counter reaction like this. Again, there is a point load of 60 Newton at this. It will be again having two components. One will be downward like this, other will be like this. Again, this will be your 60 cos 60. This will be 60 sin 60, because it is having two components. One is vertical, one is horizontal. So these two forces will counter each other, and the net will be the reaction at this point. Okay, then at the hinge support, the reaction RA can be in any direction. RAB and RB are the two components in the vertical and horizontal. As I explained you this, at the roller support, there only be a upward reaction, that is this one only, because this is the roller. A roller is kept on the ground, so it can give only a vertical reaction, not a horizontal. Horizontal, because roller will move this way. If a force is applied horizontally, then it will not give any reaction here. But hinge support will give a reaction horizontal as a vertical. But hinge support will not counter any moment. If we give a moment like this or like this, it will not counter this. Only fixed support can counter the moment, but it will counter the vertical and horizontal forces as a reaction at the hinge. So this is about the diagram. Then coming to these are the reactions RA vertical, RA vertical, and this is RA horizontal, this one. This will be only RB is shown RB because there will not be any horizontal reaction here. Only vertical reaction will be there. It is shown as RB simply. The reactions RAV, RB, RAH and RAV and RB can be evaluated by applying the conditions of equilibrium. What are these conditions? And for what? The conditions of static equilibrium for the coplanar non-concurrent force system, which is this summation F H horizontal equal to 0, summation F vertical equal to 0, and summation M equal to 0. Okay, just remember this. This will be like this only. Now, first we are taking a moment about A. Taking a moment about A. This is the point A. Just taking a moment about A, this point. What will be? That the point load acting at A will get neutralized because it is passing, its line of action is passing to the point A. Its moment about it will be 0. This 100 Newton force will give a clockwise moment. The 40 Newton force, its horizontal component will have a line of action of this horizontal component will pass through this. So its moment about this point will again be 0. Its vertical component, that is 40 sin 30, that is 40 sin 30. It will be having a moment again clockwise. This will again have a clockwise moment, and this will have a counterclockwise moment. This beam is kept on the ground. It is not moving anywhere. It means this beam is in the condition of static equilibrium under the action of these forces. The reactions at A, reaction at B, and the forces acting at A, B, A, that 200 Newton, 400 Newton, that is 40 Newton, 20 Newton. So these are the conditions of static equilibrium. So we can apply the condition summation Fx is equal to 0, summation Fy equal to 0, and summation M equal to 0. That we have applied here. So first taking moment about A and equating it to 0, 100 into 1. Then 40 sin 30 into 2 plus 20 into 4 minus RB into 5 equal to 0, which gives you like this. I think somewhere I was wrong, that he is showing that 100 okay, I am right. That is 100 Newton force acting at a 1 meter distance. Okay, no problem. Then it gives you RB this much, 44 Newton. Now summation Fx is equal to 0, then RA horizontal plus RAB, A horizontal equal plus 60 cos 60 minus 40 cos 30 equal to 0, which gives RA horizontal as 4.64 Newton. Then further summation, F vertical is equal to 0, RA vertical is equal to 60 sin 60 plus 100 minus 40 sin 30, plus 40 sin 30 plus 20 plus minus RB equal to 0. RB, okay, yes, it means RAB minus 60 sin 60 minus 100, because he has taken downward force as negative and upward force as positive. That is, reaction as positive and force as negative, and equated them. Then which gives you RAB equal to 147.96. Total reaction at the hinge, which is equal to RA, means this is the hinge which is having a vertical reaction and a horizontal reaction. Then their resultant RA will pass like this, which is RAH square plus RAB square, which comes to out to be 145 Newton. Then this angle theta will be calculated like this, that tan theta equal to RAB upon RAH, which comes out to be 88.20, means this angle will be 88.2. Now next problem 3.14. Here there are two levers. This is the seesaw type. This is the refer to this figure 3.2, show a system of levers supporting a load of 100 Newton here. Determine the reaction at A and B. We have to show the reactions at here and here. For that, just we will make use of free body diagram for these two levers separately. First, we will use a free body diagram for lever, that is CD, which is hinged at D and simply supported at C, and 100 Newton load is acting on it. Then taking moment about C for this lever, you can say this lever is like this. Here is a hinge joint, this is a roller joint here, and 100 Newton is acting like here. Then this is 2 meter and this is 3 meter. Load is 100 Newton. So its free body diagram can be drawn like this. This is your 100 Newton. This is RD and this is RC. Again, we will use the same concept, summation Fx is equal to 0, summation Fe equal to 0, and summation M equal to 0. Here summation Fx, because there is no horizontal force, so we can neglect this step. Only summation V equal to 0 means RC plus RD equal to 100. First equation will go. Then taking moment about this point, we will say 100 into 2 equal to RD into 5. So 100 into 2, 200 divided by 5 will be the 40 Newton. Then RD will come out to be 40 Newton. We will which will explain on the next slide. So this is, then we will say RD plus RC is equal to 100. So RD already 40, so RC will be 60. So we can find out RC equal to 60 Newtons. But this will be shown in the next slide. Here. Refer here. RA, that is RD into 6 is equal to RB into 2, which gives you RB is equal to now take for the another lever. Here this is your RB here, this is RC 60 Newton already. This will be a reaction here at point A. This is 4 meter, it is 2 meter. So RB will be equal to 60 plus RA. And taking a moment about this point, we can find out RB. The RB into 2 equal to 60 into 6. In that condition, RB is coming 180 Newton, and then RA plus 60 should be 180. Then RA comes out to 120 Newton. That's why we have solved this. RA 120 Newtons acting downwards here. And then RB 180 Newton acting upward here. We will go to the figure again. Here. To balance this 100 Newton, force, we require a reaction here 180 Newton and a reaction here of 120 Newton downward. Now, refer to the last problem of this class. Here we have a overhanging beam. A beam has been loaded and supported as shown in figure 3.26 given below. Determine the reaction at supports points A and B. Just refer to this beam. Here it is a hinge joint. This is the roller joint, roller support. Here there is a pure moment, anti-clockwise moment of 20 Newton meter, kilonewton meter. So the first step will be to find the equivalent point load for these two loads, this UDL and UVL. This UDL is 4 kilonewton per meter acting for a length of 2 meter. So 4 into 2, 8. This 8 kilonewton will be acting at the center of this distance. That is 1 meter from D or 1 meter from B. And then we have given this point load 8 kilonewton acting at the mid of this span. Similarly, this 100 kilonewton per meter varying load per meter length, there will be an increase of 100 kilonewton when we are moving from here to here. So here this load is 0 at this point, and here it is that is, it is on 10 kilonewton. Now some figure is somehow dim, so there is some problem for me to recollect to see the actual magnitudes. So the XQB for this. So this is 10 kilonewton per meter. So total length is 1.5 meter. So total load bit at this much will be height into base divided by 2. That 1.5 into 10, that is 15 divided by 2, that is 7.5 kilonewton, which will be acting at where? At the 1/3 from here or 2/3 from here. So 1.5 into 2 by 3, this is somewhere here. So it is 0.5 meter here from here or 1 meter from here, from E. Now total load calculated 8 kilonewton for which? For this, and this is also 7.5 kilonewton for this load. Now take the case of that load acting at an angle of 30 degree at the point E. Resolve this force vertically and horizontally. This is a vertical component like this and horizontal component like this. Angle is 30 degree, that is, it comes out to be 25 sin 30, that is 12.5 kilonewton, and 25 cos 30, that is 21.65 kilonewton. So we have converted all the UDLs and UVLs into point loads and shown on the free body diagram, your load diagram on the beam. This is the load diagram, complete. Force diagram, not load, force diagram. Now for equilibrium of the beam, as I told you earlier also, that summation F horizontal will be 0, summation F vertical will be 0, and summation M will be 0. Summation M, that is clockwise moment, must be equal to anti-clockwise moment, or summation M will be 0. Then summation Fx RAB 21.6 minus 21.6, one horizontal force only, then it is coming like this. Then vertical, equating all the vertical forces means upward going force we have taken positive and downward force we have taken negative. So RAB minus 5 minus 8 plus RB minus 7.5 minus 12.5 equal to, which comes out RAB vertical plus RB is equal to 33. Now taking moment about the end A and taking clockwise moment as positive, means this going will be taken as positive. Then 5 into 1 minus 20 is this the moment given already Newton meter, that is clockwise, so we have taken it negative. No. Let us go back to the last slide. This is counterclockwise, not clockwise. This is counterclockwise, that's why this is again negative. So 5 into 1 minus 20 plus 8 into 3 minus RB into 4. Because this RB is acting here, this is 4 meter distance from here, this is RB, it will be giving a counterclockwise movement like this. Then 7.5 into 4.5 plus 12.5 into 5.5. On solution, RB comes out to be 27.875. Then when just subtracting from the total vertical load with the RB, then it RAV will be given as 5.125. Total will be equal to, this was 33. This plus this will be 33. The reactions at supports are A vertical 20.67, RA horizontal 5.125 and RB 21.875. Now again look into this. This was beam, this is RAV and this is RAH. This will be making an angle theta like this from the horizontal. This theta will be RAH upon RAV upon RAH, vertical upon horizontal. Tan, that is theta equal to RAH. So by this we will find out theta. Now comes the resultant RA will be equal to RAH square plus RAV square. Just square them, add them and take a under root. You will find RA, which is missed in this problem. Author have not calculated RA and angle theta. You can calculate of your own. That's it from my side. Thanks for watching this video, and if you find it interesting, then give a comment on drpskaushik@gmail.com. Thank you. Thanks for watching.